Another way of dividing up substances, materials, matter, whatever, is into metals and non-metals. And we've learned about metals and non-metals since primary school, and even in grade 8 and 9, you learned that the metals were the bulk of the periodic table, and the non-metals were confined to the top right-hand corner, except for hydrogen, which kind of really doesn't belong there. It kind of belongs more like over there. But in terms of metals and non-metals, for other reasons, it does belong where it is, because you know it's got a valency of 1, and it's got 1 valence electron, which is the same as lithium, etc. But for the purpose of dividing into metals and non-metals, it is on the wrong side of the periodic table. I've got this little step ladder over here, which you've seen before. Great. But the thing that you need to understand now that you're in grade 10 is that these elements over here on either side of the step ladder are actually a little bit metallic and a little bit non-metallic. They have properties that perhaps are a bit of both. And we'll discuss that a little bit more in the meantime. But for the start off, let's look at metals and non-metals. So, elements can be classified according to a number of their different properties, and the first one we're going to look at is metals versus non-metals. You could classify them according to color, number of electrons in the outer energy level, which we've done when we were earlier, luster, how much they shine, how much they're malleable, can be hit with a mallet, in other words, hammered into shape. Luster is how much they shine, conductivity, reactivity, melting and boiling points, etc. Metals, you know from a million years ago, not really, probably about 3 or 4, but anyway, you know from a long time ago that metals are able to conduct heat, conduct electricity, shine, they can be hammered into shape. Ductile means they can be drawn into wires. You guys all know what a duct is. It's a narrow, thin tube, so ductile means that the thing can be pulled into a wire. And metals react particularly well with acids, whilst non-metals don't react with acids. And guess what? They're not ductile, they're brittle, they don't shine, they don't conduct electricity, and they don't conduct heat. Certain metals react with others to form things called alloys. An alloy is basically a metal mixture. So let's say you would put something like iron and nickel together. Then you would get properties that were different from both iron and nickel, because they would, it's not really a mixture, because they do actually kind of bond together in a metallic lattice. And they actually change their properties. Some metals have got incredible strength under pressure. As temperature decreases, the resistance of metals also decreases, which is a funny little thing. Remember, resistance is how difficult it is to get through. I'm going to talk a little bit more about that when we've got a picture in front of us of a metallic lattice at a microscopic level. And eventually, something can become a superconductor. And a superconductor has a resistance of 0 ohms. As they get closer and closer to the coldest temperature known to man, which is minus 273 degrees centigrade. Now, of course, it would be super if things didn't have resistance, because then they wouldn't make heat, and you wouldn't have to generate electricity to make electrons flow. That would be fab, but what we found is that living at minus 273 degrees is very, very cold, and it's also very difficult to get down to those kind of temperatures. A lot of metals will be superconductors a bit lower than that, at least higher than that, at let's say minus 160 degrees, but that's still very cold and very expensive to make happen. So superconductivity is awesome, and a lot of interesting stuff happening around superconductors in terms of research, but we haven't really got it to a point where we can use it. Some metals are funky because they do not rust, and you guys all know about aluminium, but it turns out that it really does rust. It just rusts so fast that it doesn't rust anymore. It creates an aluminium oxide layer on its outside. So if this was a piece of aluminium, all of these atoms will react straight away with the oxygen, creating an aluminium oxide layer, and that keeps the rest of the metal safe. So it doesn't disintegrate the way that rust would make things disintegrate. Some metals resist wear and fatigue. Only 3 metals are metallic: iron, nickel, and cobalt. And that's important to keep in mind, because we often think metals are metallic, but magnetic at least, and that they're not. They are iron, nickel, and cobalt are your only magnetic metals. But we use a lot of iron, and so we experience a lot of metals being magnetic. Some give out electrons when radiated, others take in radiation. My point with this list is that they do all sorts of things, and it's about finding the right metal for the right job. Metals are used in many substances because of their specialized properties. Metals have got few electrons in their outer energy level, and these allow them to conduct electricity. They become dislodged from the nucleus, and there's a negative region, and that's where electrons conduct. This is called metallic bonding, and it gives rise to all those properties of metal. So here's a piece of wire. They're the positive kernels, and we've got the little electrons in between. Those electrons can obviously conduct electricity. But also if I hammer this, and I kind of start bashing on this bit over here, the whole lattice will stay in place because these electrons will still hold the lattice together. And if I try and now pull this all out into a skinny little wire, I will find that the positive kernels and the electrons will just rearrange themselves and stay stuck together. Metallic bonding gives rise to the following properties of metals. They usually have high melting and boiling points because they have strong forces of attraction between the electrons and those positive kernels. They're flexible for the reason I just explained. They can conduct electricity and heat because those electrons can move through the lattice, and they're strong, and that means you can use them for machines. I was talking to you earlier about these metals over here that are the semi-metals, and they have properties that are a bit metallic and a bit non-metallic. For example, graphite is a non-metal that can conduct electricity. And each one of these elements has some fantastic properties that can be a little bit metallic and a little bit non-metallic. Certain metals that occur next to the zigzag line on the periodic table have some metallic and some non-metallic properties. These are called semi-metals or metalloids, and they are blah. They mainly have non-metallic properties, but some metallic properties as well.